Here is another work example on our series, logarithmic differentiation. We are told to evaluate the natural log of x raised to the power of 3 over 4 multiplied by the root of x squared plus 1 whole over 2x plus 1 raised to the power of 3. To solve this question, the first step is that we are going to reduce this function to the simplest form. Okay, let us proceed. Y is equals to, because the sign between x raised to the power of 3 over 4 and the root of x squared plus 1 is a product sign. And in our previous class, we learned that the natural log of a product, the product of a log is the addition of that log. Are you get what I'm saying? So for this, I'm going to have the natural log of x raised to the power of 3 over 4 plus the natural log of the square root of x squared plus 1, because the sign between x raised to the power of 3 over 4 root of x squared plus 1 and 2x plus 1 raised to the power of 3 is a quotient sign, and the log of a quotient is the difference of that log. So I'm going to subtract this from the addition of this. You understand? So I'm going to have minus, which is negative, the natural log of 2x plus 1 raised to the power of 3. Do you understand? Okay, let us proceed. Don't forget that if we have the square root of x, this is also the same thing as x raised to the power of 1 over 2. Do you understand? So in that case, the square root of x squared, the square root of x squared plus 1 is equals to x squared plus 1 raised to the power of 1 over 2. Do you understand? Okay? Another thing that I want you to note is that according to the law of logarithm, if we have the natural log of b raised to the power of a, this can be written as what? A multiplied by the natural log of b. Do you understand? That is, the log of a power is the product of that power and the log. Do you understand? These are the basic laws of logarithm. Okay, let us proceed. Now, for this, I'm going to have y is equals to, because according to this law, the log of a power is the product of that power and the log. So I'm going to have 3 over 4 multiplied by natural log of x. Do you understand? I have not done anything. I'm still reducing this function. I have not differentiated at all. You understand? So let us proceed. Plus, now for this, I'm going to replace root of x squared plus 1 as this. You understand? So for this, I'm going to have something like 1 over 2 here. Do you understand? Okay? I don't want to rewrite this here. You understand? I want to just proceed to this log by taking this 1 over 2 and multiply it by this product, by this logarithm. You understand? That's why I showed it here. Do you understand? So let us proceed. For this, I'm going to have 1 over 2 multiplied by x squared plus 1. Okay, let's proceed. Minus natural log of 2x plus 1, because I have another power here, and according to this law, I'm going to have 3 multiplied by the natural log of 2x plus 1. Do you understand? Okay, let's proceed. So now we can differentiate this function. You understand? Because we have reduced it. We have reduced this function, so it is easy to differentiate. So don't forget the basic laws of logarithmic differentiation. If we have, please, this law is very important. Y is equals to ln x. Derivative of y is equals to 1 over x multiplied by the derivative of x. Do you understand? And if you differentiate x, you're going to have 1. So 1 over x multiplied by 1, that is 1 over x. That is why you often see in differentiation that anytime we take derivative of ln x, we always have what? 1 over x. Do you understand? Okay, let's proceed. So let's proceed. For this, I'm going to have y is equals to, now, 3 over 4 multiplied by ln x. If you differentiate ln x, you can see ln x was 1 over x. So I'm going to have 1 over x put it in brackets, then put the additional sign. Let's proceed to this second part. We have 1 over 2. Oh, sorry, I didn't put lane. Yeah, sorry, I didn't put lane here. This is 1 over 2 lane. Okay, do you understand? This natural log has to be there. Okay, let's proceed. So now for this, I'm going to have 1 over 2 multiplied by x squared plus 1. If you differentiate lane x squared plus 1, don't forget, we are going to take the inverse of the function at the front of the natural log. Do you understand? So the function at the front of the natural log is what? X squared plus 1. So I'm going to take the inverse, just like I did here. I take the inverse of x, then differentiate x. I take the inverse of x, then multiply it by the derivative of x. Do you understand? So I'm going to take the inverse of this also. That is x squared plus 1 multiplied by, if you differentiate x squared plus 1, you're going to get what? 2x. So I'm going to have 2x. Do you understand? So let us proceed. For this, I'm going to have the third part of this, minus 3 multiplied by. Now, the next step is that I'm going to take the inverse of the function in the front of the natural log. That is the inverse of the function inside this bracket. That is 1 over 2x plus 1 multiplied by the derivative of 2x plus 1. If you differentiate 2x plus 1, I'm going to have 2. So for this, I'm going to have 2. Let's proceed. Now, the derivative of y. Oh, sorry. This sign is supposed to be. Yeah, supposed to put this sign. This sign means derivative, okay? So I'm going to have 3 all over 4x. Let's proceed. For this, I'm going to have 1 over 2. Oh, what happened to this marker? 1 over 2 multiplied by, now that is 2x multiplied by 1, that is what? 2x. Then I'm going to have 2x all over, that is 2x all over x squared plus 1. Do you understand? Okay. Now let us proceed. I'm going to have minus 3 all into bracket 1 over 2x multiplied by 2. This numerator will multiply 2. So I'm going to have 2 all over 2x plus 1. Do you understand? So let us proceed. The derivative of y is equals to 3 over 4x plus 2x all over, if you multiply 2 by x squared plus 1, you're going to have 2x squared plus 2 minus 3 multiplied by 2, that is what? Minus 6. So I'm going to have minus 6 all over 2x plus 1. Do you understand how I got this? So the derivative of this function is this. Do you understand? So let's proceed to the another question.